So let's begin with our endsem exam paper. First question is find the roots of the polynomial x to the power 2 minus x minus 1 through fixed point iteration method. Also make a table for the various possible equations and show their nature, whether they are convergent or divergent in nature. Assumption, let fx is equal to x square minus x minus 1, and we have taken f1 and f2. We have calculated, and hence the root is between point x is equal to 1 and x is equal to 2. So we can take x0 is equal to 1.5 as median value. Let the function fx is equal to x square minus x minus 1. Here are the following equation gx that can be made through fx. You can see this table here, gx, g dash x, g dash 1 and g dash mod of. So this g dash x right here is the differentiation of gx. Now for the selection of correct gx, mod of g dash x should be less than 1. And second, if multiple value of gx are less than 1, then choose the least one. Table for convergence. You can check here that when it is convergent and when it is divergent. Write an algorithm for finding the root of fx is equal to x square minus x minus 1 equal to 0 using the fixed point iteration method. To find the root of the function fx is equal to x square minus x minus 1 equal to 0, we can use the fixed point iteration method with an appropriate iterative equation. Here is an algorithm that outlines the process. Start with an initial guess for the root. Let's call it x0. Set a convergence criteria such as maximum number of iteration or a desired level of precision. Initialize the iteration counter. Let's call it I to 0. We will initialize the iteration counter, that is I equal to 0. Repeat the following steps until the convergence or reaching the maximum number of iteration. First, we will increment the iteration counter I equal to I plus 1. Compute the next iterate using the fixed point iteration formula xi is equal. Write an algorithm for finding the root of fx is equal to x square minus x minus 1 using the fixed point iteration method. To find the root of the function fx is equal to x square minus x minus 1 equal to 0, we can use the fixed point iteration method with an appropriate iterative equation. Here is an algorithm that outlines the process. Start with an initial guess for the root, let's call it x0. Set a convergence criteria such as maximum number of iterations or a desired level of precision. Initialize the iteration counter, let's call it I, to 0. Repeat the following steps until convergence or reaching the maximum number of iterations. Increment the iteration counter I equal to I plus 1. Compute the next iterate using the fixed point iteration formula. Xi is equal to gx I minus 1, where gx is a function that transforms x. Check for convergence if mod of xi minus 1 is less than tolerance, the solution has converged. Exit the loop. If the maximum number of iteration I is reached, the method did not converge. Exit the loop. If the solution converged, output xi as the appropriate root of fx is equal to 0. Otherwise, output an error message indicating that the method did not converge. The choice of the function gx depends on the problem. In this case, we can rewrite the equation fx is equal to x square minus x minus 1 equal to 0 as x is equal to gx and solve for gx to obtain the iterative equation. Write the output of the algorithm of question 1, part B. The gx is equal to root of x plus 1 should be taken for the fixed point iteration method. X0 is equal to 1.5, x1 is less than or equal to root of 1.5 plus 1, x1 is equal to root of 2.5 equal to 1.5811. x2 is equal to root of 1.5811 plus 1 equal to root of 2.5811 equal to 1.6065. And hence we'll calculate the x3, x4, value of x3, x4, x5, x6 and x7. And as we can see, the error between x7 and x6 is 0.000101. Hence root of x square minus x minus 1 is 1.618001. Question 2. Write the algorithm for the Gauss elimination method with pivoting. Input a system of linear equation represented by an augmented matrix A. Set the current pivot row to 1 for each column J from 1 to the number of columns in A minus 1 to the following. First, find the row I of current row with the largest absolute value in column J starting from the current pivot row. Second step, swap the current pivot row with row I. And third step, if the value in the pivot position A, current row J is 0, continue to the next column. For each row, I from the current pivot row plus 1 to the number of rows in A to the following. A. Calculate the multiplier M equal to Aij divided by A of current row and J, the ratio of the current element to the pivot element. For each column K from J to the number of columns in A, update Aik equal to Aik minus M into A of current row and K. Third step is set Aij to 0 to ensure numerical stability and eliminate rounding errors. If the current pivot row is less than the number of rows in A, increment the current pivot row by 1 and go to the step 3. Otherwise, continue to the next step. Back substitution, starting from the last row and working upwards, solve the unknowns. Set each variable x n, where n is the number of columns in A, to a n n plus 1 upon a n n. For each row I from n minus 1 to 1, calculate xi equal to ai n plus 1 minus summation of aik into xk upon aii, where k goes from I plus 1 to n. Now our second question is find the solution of the system of equation using iterative method. Our equations are 20a plus b minus 2c equal to 17, 3a plus 20b minus c equal to minus 18, 2a minus 3b plus 20c equal to 17. We find the value of a, b, c in respective equation by taking variables from one side. We will calculate a, b and c. Now let a0 equal to b, a0 equal to 0, b0 equal to 0, c0 equal to 0, a equal to 17 plus 0 plus 0 divided by 20. We will calculate the value of a, b and c by that equation, and our a1 is equal to 0.85, b1 is equal to minus 0.9, c1 is equal to 0.85. Same as we will calculate the value of a2, b2, c2, a3, b3, c3 and a4, b4, c4. Now we will follow these steps till we get repeated approximate values. Our third question is list out 4 disadvantages of Gauss eliminations and 3 advantages of iteration methods over the elimination method. The iterative method is superior to the elimination method due: first, computational effort is approximately 2 n into 2 arithmetic operations per iteration, and if convergence is achieved in less than n iterations, it is significantly superior compared to the elimination method. Second, another important advantage of the iteration method is small rounding error, the rounding error being the one committed in the last iteration. Thus, for ill-conditioned system, an iterative method is a good choice. Third, in Gauss-Seidel method, we set xi equal to the newly calculated value of the iterated stored in temp. The disadvantage of Gauss elimination are as follows. The computational effort is approximately 2n 3 by 3. Arithmetic operation in each elimination step. Second, the amount of bookkeeping necessary is considerable. Third, the rounding error may become quite large, particularly for ill-conditioned equations. And fourth, any special structure in the matrix of coefficient is difficult to preserve during elimination. Third question is, obtain the estimate of the missing figures using del E operator in the following data. We will make the table of x and y, and then we will calculate the missing figures. First, we have to find the corresponding values from 2.1 and 2.4, and here we will use the Lagrange's interpolation method. So let's begin. We know the formula of Lagrange's interpolation method, how to calculate. Yx is equal to x minus x2 into x minus x3 into x minus x4 into x minus x5 upon x1 minus x2, x1 minus x3, x1 minus x4, x1 minus x5 into y1 plus x minus x1 into x minus x3 into x minus x4 into x minus x5 divided by x2 minus x1 into x2 minus x3 into x2 minus x4 into x2 minus x5 whole multiplied by y2. And same like this we will calculate for y3, y4, y5, and we'll add all the values, and at the last we will get the answer in terms of x, and then we will put the value of x is equal to 2.4. On solving the above equation, after putting value of x is equal to 2.4, we'll get y 2.4 is equal to 0.088, and now we will calculate the same thing for x is equal to 2.1. Second question, in an examination, the number of students who obtained marks between certain limits were as follows. Marks range is given from 0 to 40, 40 to 45, 45 to 50, and so on. Determine the number of students who secured more than 48 but not more than 50 marks, and who secured less than 48 but not less than 45 marks. First, we will make the table. We will calculate del fx and del 2 fx, del 3 fx, and del 4 fx. How will calculate this? The difference from this 253 minus 210 is written here 43, and difference of 307 and 253 is written here. 381 minus 307 is written here, and same we will go for del 2 fx. 54 minus 43, the result is written here. 74 minus 54, the result is written here, and we will go up to del 5x. For f of 48, a plus uh is equal to x, 40, a is equal to 40, h is equal to 5, and x is equal to 48. So we'll calculate the value of u, which is equal to 8 by 5. Now we will write the formula for f. A plus uh is equal to fa plus u upon 1 factorial del fa plus u into u minus 1 upon 2 factorial del 2 fa plus u into u minus 1 into u minus 2 upon 3 factorial del 3 fa, and so on up to del 5 fa. Now we will put the values of fa, u, and we'll calculate the value for f of a plus uh, and at final value will get 280. So the number of students who secured below 48 marks is 280. Now first, secured more than 48 but not more than 50 marks is equal to number of students scored below 50 marks minus number of students scored below 48 marks, and we'll get the result as 27 students. For calculating the students who secured less than 48 but not less than 45 marks, we have to subtract the number of students scored below 45 marks from number of students scored below 48 marks. So 280 minus 253 is equal to 27 students. Now third question is, write the algorithm for the Lagrange inverse interpolation. First step is read number of inputs n. Second step is read the value of x. Third step is for I equal to 0 to I equal to n minus 1. Read xi, yi. Fourth set sum equal to 0. Fifth step is for I equal to 0 to I equal to n minus 1. Guys, this is loop. So we will set the product equal to 1, and for j equal to 0 to j equal to n minus 1. If I is not equal to j, product is equal to product into y minus y1 upon y1 minus yj, and sum equal to sum plus xi into product, and at last will print sum. Question number 4th. First part, evaluate the integrate 1 by 1 plus x square dx from 0 to 1 using the 3-point Gauss quadrant formula for the given abscissa and weight. T1 is equal to 0.77459667. Value of T2 is equal to 0 and T3 is equals to minus T1. W1 is equal to minus 0.555556. W2 equal to 0.8889 and W3 equal to W1. Let A equal to 0, B equal to 1, X is equal to B minus A upon 2 into T plus B plus A divided by 2. Putting the values of A and Bi, X is equal to 1 plus T by 2, Tx is equal to Dt by 2. Substituting the value of X and Dx and the Fx, Ft is equal to integrate 2 divided by 4 plus 1 plus T into 2 dt from 1 minus 1 to 1. Ft is equal to 0.55556 f minus 0.7745 plus f of 0.7745 plus 0.888889 f of 0. Integrate, will get the value. And now second question was, derive Simpson's rule using Newton's Cotes formula. Simpson's rule is a numerical integration method that approximates a definite integral of a function using quadratic polynomials. It can be derived from Newton's Cotes formula, which are a family of numerical integration formula that approximate the integral of a function using equally spaced points. Let's start by considering the interval AB and dividing it into subintervals of equal width h. The points where we will evaluate the function are a plus h, a plus 2h up to b minus h, b, which gives us a total of n plus 1 equal space points, where n is the number of subintervals. The general form of Newton-Cotes formula for equally spaced point is integration of a comma b fx dx equal to h into w0 into f of x0 plus w1 into f of x1 plus w2 into f of x2 plus goes up to wn into f of xn, where x0 is equal to a, x1 is equal to a plus h, x2 is equal to a plus 2h, and similarly it goes on up to xn is equal to b, and w0, w1, w2 up to wn are the weights associated with the corresponding function values. For Simpson rule, we consider n to be even. In this case, we divide the interval a comma b into n by 2 subintervals, with each subinterval having a width of 2h. The points where we evaluate the function are a plus 2h, a plus 4h up to b minus 2h, b give us total of n by 2 plus 1 equally spaced point. Now we need to determine the weights w0, w1, w2 up to wn for Simpson rule. For Simpson rule, the weight for Newton-Cotes formula given by w0 equal to w2 equal to w4 equal to all the even are equal to 2 by 3 and all the odd weight is equal to 4 by 3, and wn is equal to 1 by 3. Substituting these weights into the Newton-Cotes formula, we get integration. Simplifying the expression, we obtain Simpson rule. A comma b of f of x dx is equal to h by 3 f of a plus f 4f of a plus h plus 2f of a plus 2h plus 4f of a plus 3h plus goes up to 2f of b minus 2h plus 4f of b minus h plus f of b. Third question is write an algorithm to evaluate Wedel's rule for the 6 points. First, read start, read end, h equal to n minus start upon 6. For we will start a loop here where I goes from 0 to 6i. Read yi, s equal to 0.3h, y0 plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus y6 and will print s. Now question number 5th is first question. Write the algorithm from the Runge-Gupta fourth order expression. Define f of x comma y. Return expression. Read starting ending splits. H is equal to ending minus starting upon splits. While starting is less than or equal to ending. This is while loop. K1 is equal to h into f of x comma y. K2 is equal to h into f of x plus h by 2 comma y plus k1 by 2. K3 is equal to h into f of x plus h by 2 plus, comma y plus k2 by 2. K4 is equal to h into f of x plus h comma y plus k3. X is equal to x plus h. Starting is equal to starting plus h. Y is equal to k1 plus 2k2 plus 2k3 plus k4 divided by 6. We will print x comma y. Second question is apply predictor correct method to solve d by dx of y is equal to minus xy, where y 0 is equal to 1 in steps of 0.1 up to y 0.2. Y 0.2 equal to y0 plus 2hf of x 0.1 comma y 0.1 predicted. Y 0.2 equal to 1 plus 2 into 0.1 minus 0.1 into 0.9975. Y of 0.2 is equal to 0.98005. Y equal to y of 0.2 equal to y 0.1 plus h by 2 of f of x of 0.1 comma y 0.1 plus f x 0.2 plus y 0.2 predicted, and we'll get the value of y 0.2 is equal to 0.982712. We can apply correct formula again for more accurate value by putting this corrected value as predicted value in the corrector formula. Third question is apply the least square principle to fit a parabola and the given data sets. Develop an algorithm for this best fit parabola. To fit a parabola to a given set of data using the least square principle, we can follow these steps. Step 1, gather the data, collect the data points xi, y1, yi from the given problem or data set. Step 2, define the model. We assume the equation of a parabola y equal to ax square plus bx plus c, where a comma b comma c are the coefficients to be determined. Step 3, set up the system of equation for each data point xi, yi. We have axi square plus bxi plus c equal to yi. Rearrange the equation to axi square plus bxi equal to yi minus c. Step 4 is apply the least square principle. Square each equation and sum them up over all data points. Summation of axi square plus bxi whole square is equal to summation of yi minus c whole square. Expand the equation expressed in terms of the coefficients a comma b comma c. Now step 5, solve the system of equation. Express the above equation as a system of linear equations in terms of coefficients a comma b and c. Solve the system of equation using standard methods such as matrix operation or Gaussian elimination. Step 6, calculate the best fit parabola. Once the coefficients a, b and c are determined, the best fit parabola equation is obtained. Y equal to ax square plus bx plus c. Thank you.